tiny bit different format. So just a plain inverse variation, y equals k over x. The inverse square just means that the x is squared. So it's going to be in the format y equals some number over x squared. Now, we'll get to this on the back in a second. I'm just going to have you guys graph these by hand like we did yesterday, just on these first two examples. So just as one example, I did 2 over x squared, and then I did negative 2 over x squared for the second example. So we're just going to go through these like we did yesterday. So I'm going to give you a little table, so I'm going to give you values to plug in for x. So I just picked a couple of things. What's going to happen, since I have 2 over x squared, I'm going to take my x value and square it. If I plug in negative 2 and I square that, what happens to the negative 2? It becomes positive 4. Okay, so whenever you square something, it always becomes positive, right? Negative 2 times negative 2 is positive 4. 2 over 4 would be a half for that first one, but I just want you to think about this for a second. If your k value, for my example here, it's positive 2, but if my k value is positive, right, and whatever I plug in for x, doesn't matter, negative or positive, if I'm squaring something, it always makes it positive. We will always have a situation in this scenario then where I'd have a positive number divided by a positive number, which is always going to result in another positive number. Okay, so all these values in the table are going to be positive because we're going to square these x values. All right, so if I do 2 over negative 1 squared, that's just 2 over 1. Thank you, I didn't realize that somebody knocked. This is going to be 2. If you do, and then now, when you square the negative 1/2, right? So if I do 2 over negative 1/2 squared, that would become 2 over positive 1/4, which you guys can just do this in your calculator, but it'd really be 2 times 4, so that's why this is going to end up being 8. The negative gets canceled, so those are all positive. Now, just like yesterday, if I do 2 divided by 0 squared, 0 squared is 0. You are not allowed to divide by 0, so that's going to be a creation of your asymptote there. And then the rest of these will be exactly the same numbers. They're not going to change the sign because we're going to square. That gives us the same value in the denominator, same value in the numerator. So those are going to be identical to what you wrote for their negative counterpart. Now, if you want to come over to the graph, and it doesn't have to be perfect, just kind of estimate if it's on a decimal. So like negative 2/2, maybe right in there. Negative 1, 2, that's the only one that's on a nice point. And negative 1/2, I'm just going to go in between 0 and negative 1, and I'll go up to 8. And I know this is only 3 points. This makes a branch like it did yesterday. So you're just going to kind of hug into that second quadrant there when you graph that. And the difference from inverse square, which is what we're doing today, and just an inverse, is the branches are going to be in the same part of the graph. Like they'll either both go up or they'll both go down. So in this case, the branch, it's just going to be a mirror image over the y-axis if you plot these points. So the branches are both going to point the same direction here. And very similar to yesterday, you are going to have a vertical asymptote, which for this example would be x equals 0. You will have a horizontal asymptote. For this example, it will be y equals 0. And I'm just going to ask you guys about domain and range here. So what would you tell me for the possible x values for the graph of the inverse square where the k value is positive? Yes, this one is all real numbers, just like yesterday, all real numbers, but not that asymptote in the middle, because one of the branches does go to the left forever, one goes to the right forever. We just never touch here in the middle, so that's 0 for this graph. Now, what would the range be? Yes, the range is different. So yesterday we were doing the inverse variation. One branch would point down and one would point up. The inverse square, both branches will point the same direction. So these both point up. There's no part of these branches underneath that asymptote. So it's just going to be an interval 0, and then it's going to go up forever to infinity. The range would just start with your horizontal asymptote, which is y equals 0 there. So 0, and then it goes up forever to infinity. All right, now I'm going to just switch up the number on the top real quick. So for this lovely table, I just made the k value -2. So this is -2 over x squared. So if I were to plug in -2 for my x, still squaring that is going to make that positive. But because I had a negative number on the top, that's my k value, that's actually going to make this a -1/2. Because what I have here, I have a negative number on the top. Whatever I plug in for x, when I square it, it's going to make that positive. So in every situation here, I'd have a negative number divided by a positive number, which would always give me what kind of a number? Negative. If you do a negative divided by a positive, that'll always result in a negative value. So all these table values, they're going to be what we just wrote down in the previous table. It's just going to be, they're all negative. This is going to flip that graph right over the x-axis. So this would be just -2, -8. 0 is still going to be a problem. You cannot divide by 0, so that's going to create your asymptote. But then also these values, these will all be negative. When I square the x value, it makes it positive, but I'm always going to take -2 for this example divided by a positive number. So that's always going to result in a negative number. So the branches are going to be really similar. They're just going to both go the same direction here, and they're going to point down. So it's going to kind of flip over the x-axis from what we just graphed. So again, just kind of estimate the only nice, ooh, I just drew that on the wrong, forgive me, not that one, -1, -2, and then -1/2, -8. And then the other branch should be a reflection right over the y-axis. So you got your two branches here. Just kind of hug into the quadrant. Very similar to an inverse variation. It's just the branches are both going to either point up, or in this case, they both point down. Now, you still have y equals 0, that's your horizontal asymptote. X equals 0, that is your vertical asymptote, and my marker is going to die. Okay. Now, for this one, right, I go left and right forever, but I don't touch here in between the two branches. So the all real numbers, but not 0. What would you write for the range for this graph if both of the branches are pointing down? Perfect. Okay, so this one, you got to start with the lowest possible value in your interval, so -infinity, and then the asymptote actually stops the top of the graph. So this would cap it off. That would be at 0. Is anybody having a question? Okay, do me a quick favor on the bottom here. I intended for these to say x squared so we could compare the inverse square variation, which is the entire theme for today, but I totally just put an x and not an x squared. So just pretend those are squared, and then I'm just going to pull up my Desmos so you guys can see how, if I change that number on the top, like how does that affect the graph. So I'm just going to grab my Desmos here real quick. So it's very similar to yesterday. So if I do, make that bigger so we can see it. Okay, let's say I did y equals 2 over x squared. Both of the branches go the same way, right? If I change the top number and I do 4 over x squared, it just pulls it back a little bit from the origin, just like it did yesterday. It's just the branches are going to go the same direction. If I do y equals 8 over x squared, again, it's same asymptote, same domain and range. It's just kind of pulled a little bit further away from the origin as you increase that number. Now, if you're looking at the notes, right under that example, it tells you to just change that top number to negative. All that's going to do, if I put a negative there, it's just going to take that and flip it down. It's the same distance from the origin and everything else. It literally just takes it, flips it over the x-axis. So it's still, as I change the number on the top, it's going to pull it away from the origin, but it's just going to flip a different direction. It's not going to be differently spaced or anything like that. Asymptote same, domain the same, range the same. And you guys can always use Desmos anytime you want. It's free to look these up. But how does increasing that value affect the graph? Basically, it just moves the branches away from the origin. Same shape, same asymptote, same domain, same range. It's just a little bit further away from the origin. And then all the k value does, if I make it negative, is flips the branches over the x-axis. So instead of both of them going up, if I change it to be a negative number, they're just going to both go down. Is anybody having a question? Yeah. Okay. Now, shifting works just like it did yesterday. The one thing that's going to be a little bit different is going to be, yeah. Yeah. Okay, I'm so glad you asked that because everybody's always like, why? It's the y-axis. Why isn't it that point? Okay. So why is this called x equals 0? So would you be okay if the origin's the point 0, 0, right? This would be the point 0, negative 1, 0, negative 2, 0, negative 3. And I know that's weird, but all the x coordinates as you go up and down this line, the x coordinates are all 0. The y's change as you go, but the definition there that the x coordinate is 0, every point on that line has an x coordinate of 0. Any vertical line, if I call it vertexal and horizontal to help me remember it because it doesn't make sense because it's the different axis, but all these x values are 0. Now for the y, kind of the same thing. If you have any horizontal line, right, this is 0, 0, this is 1, 0 as the y, 2, 0, 3, 0, 4, 0. So if all the y coordinates are the same, it creates a horizontal line. The x's change as you go left and right, but all the y's are consistent. And I know that's weird because it's the opposite of how the axis is labeled, and that's why that throws people off. But that's a really good question. Does anybody else have a question? I'm so glad you asked that because I think that confuses people a lot of the time. Okay, now on the back. This is going to work just like it did yesterday. Now, the one thing I want to have you keep in mind, so a lot of the fractions you guys are going to see within these problems, if you look down the page like a little bit, do not FOIL the bottom of that fraction. That is not the intention. Don't do that. Leave it in that format where it's squared. The squared is going to indicate to you that the two branches are going to go the same direction, but leave it in that format because then you can tell what the asymptote is. So don't FOIL anything out here. With the x in the parentheses, and that'll be squared, it's still going to go the opposite way you think. And that would shift this graph left or right. It's always with the x, it's going to go opposite how you think it looks in the problem. And then outside the fraction, if we're over to the side, I've got a plus c. This is going to move the graph up or down, and then the way you think. Okay, now, this is going to be depending on what the k value looks like, how this would look. So if the k value is positive, so if on top your constant of variation is positive, and you've got something that's squared in the bottom, both of your branches are going to point up. And maybe I should have written this on the front, but they would be in quadrants 1 and 2 would be the quadrants that they would fall in. Okay, it's very similar to yesterday. X equals B is going to be your vertical asymptote. Y equals C, whatever's added or subtracted to the sign, that's going to be your horizontal asymptote. Now, the domain is identical to yesterday. All the real numbers, but not whatever your vertical asymptote is. That'll be B in the equation. The range is what's different. So the range for this one, since the k value is positive and both branches go up, it should start with your asymptote, which would be the, oh my gosh, no, it would be the c value, whatever you're shifting up or down. I don't know why that's such a bright color today. And then it's going to go up forever to infinity. If the k value is negative, then that flips both of the branches to go the same direction. As long as the x is squared, it would be in quadrants 3 and 4. X would still be equal to B for your vertical asymptote. Y would be equal to C for your horizontal asymptote. Domain, all the real numbers, but not that vertical asymptote, which is B. And then the range here, since they both point down, you'd want to start your interval with the negative infinity, and it would stop at your horizontal asymptote, which would be C. So that would be a general format, and then you could fill in the B and C based on the equation. Okay, let me scooch this up a little bit. So really, like yesterday, we're just going to look at the number on the top, and that's just going to indicate to us, like, how should our branches go? We're not going to plot specific points. So in this first example here, I just have an 8 on the top as the K value. So if I have 8 on the top, I automatically know both of my branches are going to point up, they're going to go the same direction. I just need to use the other numbers in that equation to tell me how to shift my X and Y axis. So how would I move if I have X plus 3 squared in the bottom and then a plus 2 on the outside? Like left, right, up, down, how would that graph move? Yeah. Exactly. Okay, so this is left 3. So I'm going to go 1, 2, 3 to the left. It's going to be my vertical asymptote. And then up 2, that's going to be my horizontal asymptote. And if you want to draw your branches, just base them on the quadrants that you created from the asymptotes. So X is opposite of what it looks like, so negative 3. Y we're going to copy, so Y equals 2, that's the horizontal line. Domain, I'm not even graphing this yet. I know it's going to be all real numbers, but not negative 3. And then let me put these branches on the graph. So because it's positive on the top and squared in the bottom, both branches are going to go same direction. And they're both going to go up because of that positive 8. The range here, I don't start touching any part of that graph until I hop over the asymptote, which is at 2. So my range would go from 2, and then it goes up forever to infinity. All right, if I look at the one directly next to this, I have a negative 4 on the top. The only thing that's going to be used for is to tell me what quadrants my branches are in. So these are both going to go down. They're being in quadrants 3 and 4 after I get my asymptotes on here. So then on the bottom of the fraction, I have x minus 2, that's squared, and I have a minus 5 on the outside. So how would this graph be shifted? Left, right, up, down. Perfect. Okay, so we're going to go to the right 2. Vertical line at 2, and then down 5. All right, so x is positive 2. So it looks like x minus 2 in the problem. It's actually what you would plug in there to make that 0. That's why I keep telling you guys it's the opposite, because it's what makes that 0 not allowed to divide by 0 that creates your asymptote. The negative 5 on the outside, that's your y. Domain, all the real numbers, but not 2. And then let me quick put my branches on here. Because I had a negative 4 on the top and I had a squared as part of the bottom of this, I know both of the branches have to point the same direction, which is going to be down because of the negative 4 as my K value. When I write my range here, I just have to do negative infinity to start my interval because it points down forever, and then it's actually stopped at that asymptote, which is up on this question at negative 5. And then there's no graph above that. The branches both point down. Is anybody having a question? Okay. I'm going to have you guys try to write some equations down here of a translation based on either a description or I'm going to give you some asymptotes. So here, I'm going to shift, and then we'll just sketch a picture of the graph. So I'm going to shift y equals 5 over x squared. So before I even start the problem, because it's 5 on the top, I know that both of the branches are going to point up. It doesn't say anything in my description about a reflection or anything like that, so it's just going to stay 5. If I want to write the equation, I'm going to go ahead and just kind of leave the y equals, and we'll leave the 5 on the top. That should not be altered by changing asymptotes. If I want to move the graph left 2 units and down 1 unit, how could I fill in the rest of that equation so it would match up with that description? Perfect, x plus 2. And then just put a little squared on it since we're talking about x squared on the bottom of the original. Don't FOIL, just leave it like that. And then minus 1. And if you guys want to come over and sketch this real quick, left 2, I'm going to go left 2 and down 1. So my asymptotes would be, and this doesn't have to be perfect. I know this graph is blank, just kind of sketch it. So x is negative 2, y is negative 1. Those would be my asymptotes. And then because the number on top is positive, both of the branches are going to just kind of hug into quadrants 1 and 2 based on my asymptotes, and they should both go up. Now I'm going to take that same equation, y equals 5 over x squared, my inverse square here, and it says I want the asymptotes to be x equals 0 and y equals 3. So I'm just going to start, and I'm going to go ahead and copy that y equals 5 over. Okay, if I want my vertical asymptote to be 0, so x equals 0, my horizontal to be 3, y equals 3, what would the equation look like? What would you put in the bottom of the fraction? Yeah. Just x squared. You're not moving left or right. X equals 0 means 0 would be a problem in the denominator, so it's just going to be x squared. Whatever the y is, just add that or subtract that to the side of the fraction. It's positive 3, so I'm going to put plus 3. All right, if I wanted to sketch a picture of the graph there, since I'm not moving left or right, x equals 0, the y-axis is just not going to move. It would just stay right where it's at. And then I would go up 1, 2, 3. Well, just making a little dotted line. It doesn't have to be perfect. We're just sketching this. And then because that 5 on top is positive and the squared is on the bottom, both branches go the same direction, and they're both going to point up there. So maybe a little sketch like that. Okay. Now, down here, the equation they want us to start with has a similar, but it's got a negative 5 on the top. So if I've got negative 5 over x squared. Now, that should not affect how you do the asymptotes. Those should be exactly the same no matter what. And so I'm just going to write y equals negative 5 on the top. Now, if it's x equals 3, it's going to be x minus 3, and I'm going to square that because we're working with an inverse square. Don't FOIL it, just write it in that format, but you'd want to see the squared if we're working with an inverse square. And then y equals 1, so then that would be plus 1. The difference here between this and the last two graphs, the branches, because of the negative 5, are both going to point down. So I'd go like 1, 2, 3, and then up 1, just kind of sketching this. It doesn't have to be perfect. Both branches would go kind of curve into quadrants 3 and 4 here, but based on your asymptotes. After you do the shifting, then go ahead and use quadrants 3 and 4. And then I have one more real quick here. I have negative 5 over x squared, and it just says up 4 units. So up or down is going to go outside of that fraction. So I'm going to write y equals, it's going to stay negative 5 over x squared, but then it's going to go up 4 plus 4 to the side. Moving up or down is not part of the fraction, it's just to the side of it. And this is actually similar to the question right above. The x-axis, or sorry, the y-axis, x equals 0, is going to be your vertical asymptote. And I'm going to go up 1, 2, 3, 4. This is different from the graph above because I have a negative number on the top. So then both branches have to point the same direction, which if it's negative on the top would be down. So in quadrants 3 and 4 after you get your asymptotes sketched in there. Is anybody having a question?